Day 9, Encoding Error. Even more alliteration here. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect your computer to it through the clever use of several paper clips. Upon connection, the port outputs a series of numbers, your puzzle input. The data appears to be encrypted with the Exchange Masking Addition System, XMAS, which conveniently for you is an old cipher with an important weakness. XMAS starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of these two of those numbers. 26 would be a valid number, as it could be 1 plus 25, or 2 and 24. 49 would be a valid next number, as it is the sum of 24 and 25. 100 would not be valid. No two of the previous 25 numbers sum to 100. 50 would also not be valid. Although 25 appears in the previous numbers, the two numbers in the pair must be different. So, are these pairs of numbers? The sum of any two of the 25. And it's the previous number. Here is a larger example, which only considers the previous 5 numbers. So we might need to take into account this preamble size. This is 5. Preamble length of 5, 1, 2, 3, 4, 5. 40 would be valid because it's 25 and 15. Almost every number is the sum of two of the previous 5 numbers. And, okay, so the preamble, it's almost like we have a buffer here, and it's kind of a rolling buffer of these numbers here. So this 102 would be it could be the sum of the previous 5. In this example, after the 5-number preamble, almost every number is the sum of two of the previous 5 numbers. The only number that does not follow this rule is 127. The first step of attacking the weakness in the XMAS data is to find the first number in the list after the preamble, which is not the sum of two of the 25 numbers before it. What is the first number that does not have this property? Okay, so we need to consider a couple things here. We need to consider the preamble, and then we basically need to search through the preamble and select two unique numbers that add together to that sum. So this is kind of similar to this expense report solver, where we were doing pairs of numbers. So we could take a combinatorial approach here. We could have a rolling buffer that's a set of all these numbers. Actually, I think a stack would be the way. So then, like, you have this rolling stack of numbers, and then, or maybe a queue. You have a queue of numbers. You're pushing new ones onto the queue. The last number is falling off. Implementation doesn't matter too much, but we have a rolling buffer of an ordered numbers in order, and then the last one falls off as we progress through this list. And then we could take a combinatorial approach where we take the combination of every number or pairs of numbers in that set, and we just do a search for them to see if any of them sum up to that current number. So we could that's the brute force solution, I think, is the combinatorial approach that we took with this first expense report solver. So first I want to parse this. This is going to be really straightforward. We're just parsing these to ints. I might even modify this to be just so I can. I might just create like a parse input method that's generic, and I can pass in a method by which I'm parsing each line of input. Does that make sense? That wouldn't, although that wouldn't work for, that would not work for the passport one where it's separated by new lines. But it could work for this. So I'm just gonna do parse input, and then this will be a function that just parses input that's line separated. And then this will return a list of whatever t is, and then so I'm gonna make a I can never remember the syntax of Kotlin Generics. So I want a Kotlin method that returns generic. Functions with generic return type. Okay, yeah, so I just want these open brackets here. T is any, and then this is going to return a list of T. Oops, I'm going to get rid of this. This parse input is going to be, we want to take this class, we want to take a file name, and then Kotlin has this thing called trailing closures so that we can use, that's a method. We want something that converts a string to, this is a converter, and this will convert whatever line of input is to this T, all right? This might even, I might even say mapper. This is some kind of method that converts a string value to a T, and then I'm gonna do readlines.map, and then so I can just pass in that mapper, and then that'll parse it to string. So in this case, we can just get we can use this method, parse input. I'm gonna create a new, first I'm going to create this new file, this text file for our input, day9.txt, and we're going to copy this. Create a day9 package. And it's just going to be a day9 test. Let's create a test method. I'm just going to parse this input for now. And so val input is equal to test util dot parse input, and we want to just pass in this class and then the day9.txt that we just created, and then this is going to be our method that takes actually we can do, this is a trailing closure here, or we'll just do this, and then it is our string, so that's going to be the context of that is the line, and so we just want to do it.toInt, and that gives us a list of ints, and we can just do that inline here, and input.size should be however long that is, day9.txt. This is 20 lines. It should be 20. So let's just make sure, whoops. let's just take a look at, we'll set a breakpoint. Let's just take a look at what this gives us. Make sure that our method is correct here. Okay, so we have a size of 20, which is what we want. 35, 20, 15. Yep, we're good. So I think I'm going to create a class that does, so I can encapsulate this preamble. Day 9. I'm going to name this XMAS. We're basically finding the anomaly in here. I'm going to name it XMAS decoder. IntelliJ is frozen. A decoder of Christmas. Okay, so then we're going to give our input as a list of int. I think we'll make this a private val so we can reference it. I'm going to create a. We actually also want to pass in the preamble size. Private val preamble. Okay, so in this case, the preamble is going to be 5. We can test this on this little set here, and then. We want to create a queue, I think, to hold this. We don't even need to do that. We can just we can grab a sublist of this, and that will be our preamble. So I'm not going to worry about making a queue. We already have that here. We do need to keep track of the number that we're on currently. We can also skip over the first n numbers in the preamble. So I'm going to go, I'm going to make a function that's find first anomaly, and that's going to return an int, and that's going to be the value of returns value of first int in input that is not the sum of the previous n numbers in the preamble. Okay. So what we need is we need to keep track of where we are. I'm going to do for I in input dot indices, and what I need to do is keep track of where I am. And initially, I'm going to initialize that to the preamble size. But we already kind of know that, right? We already know where we are. So this is not really, hang on a second. We actually want, the range that we want to look at is I'm going to create a new variable called inspect range. And that's the range that we actually want to look at. So this is going to be a range from preamble size to the input dot size. So now we actually want to do for I in inspect range. So that's actually what we want. Okay. So essentially, like if the preamble length is 5, we don't actually need to look at this because we can't look back from here. We want to skip to index 5 and then look back on this preamble. And this is 0 indexed. So val current is I, or it's input of I. And then we want to generate, we need to generate a set or a list or some kind of collection of all the possible sums in the previous 5. And we need to, so in order to get these sums, this is going to be a list of int. This will be a list of possible sums. It's going to be private. We're going to need to know what the previous 5 are. But we really only need the start index, because we know the preamble size here. So I'm going to have, I'm going to just pass in start index as an int, and then I'm going to use that combinatorial library that I used for this combinatorial solver. Combinations here. And we want to use combinations because these need to be unique combinations of the previous numbers. And we could actually, I'm actually going to just generate the sums here. I'm going to separate that out just to do that. Get sums. So we want to do the so we can do, I think this, what this library does is it adds a, we want it to, I think it adds an extension function onto the list, right? So this expenses a list of int, and then this combinations is just an extension function on that iterable. Okay, so we need to basically get a sublist. We need to get the preamble given a start index. So I might actually have a separate method just to separate these concerns out. Get preamble, and then we're going to pass in the start index. As an int. So this is going to be, we want to do input.sublist start index. So the from index is going to be this, and then this is going to be a list of int. So this input is going to return, we want to input.sublist, and I need to say fun here. Input.sublist, we want the start index, and then we want the start index plus preamble size. And this always trips me up. I think this is exclusive, which is okay, I think. Two indexes exclusive. I think that's okay. I think we're okay. So essentially we want to do get preamble with this start index, and then we'll do combinations, and we just want 2. We just want pairs. And I think that what I could do is parameterize this, but I think I'm going to hold off on that. I have a feeling he might ask us in the next step to use 3 different numbers in the sum. So it's, in which case it'd be very similar to the expense report, but I'm not going to parameterize this for now. So we want to do combinations, and then I think, can I just do like toList? Oh, except this is going to be pairs. So we want to map this. This is going to be combinations. We do want to map this to combinatorial sequence list of t. How did we do this? It.sum. Oh yeah, so that's what we want to do. We want to do a map of this of the sum of these numbers. Why is that complaining? I guess we just have to output it as a list. Okay. So current is input I. Val sums is equal to get sums, and then we want the start index is going to be current minus the preamble size. So we're at, like, let's say we're at 40, and then our start index would be minus 1, 2, 3, 4, 5, so it'd be 35. And then this will take that input and then get a sub list of that, and then it will compute the sums. And then we just want to do if sums, if our current is not, if our current is not in sums, then we want, oh, I can just do that. Okay, not in sums. Then we want to just return current. And that will give us, we're going in order. We're walking through this list. We're getting the sums. We're checking to see if this current item is in the sums. Otherwise, we return current. And then I'm just going to throw an exception here. No anomalies found. Okay, so day 9 test. I'm going to rename this to Christmas decoder test. And then let's just try it out on this input. So we're going to parse this input. I'm going to just copy this. Find anomaly in test input. So we're going to parse that, same as we did. And then we're going to create a new XMAS decoder. So valid decoder is new XMAS decoder. We're going to pass in that input, and then we're going to give it a preamble size of 5. Oh, other way around. I mixed up my parameters. So preamble size is 5. We're going to give it the input. Val first anomaly. I'm just going to do decoder dot first or dot find first anomaly dot first. Can I do that? Oh no, that is returning the anomaly. Should be 127. Let's try it out. My one concern is if I got some of the indexes wrong, and sure enough, index out of bounds. This 2 index is 40. Input.sublist, start index plus preamble size. How is that possible? I'm going to set a conditional breakpoint here. I want to see why this happened, because it should have gotten here. Should have gotten to 127 and then return that, right? So I'm going to say my condition is start index plus preamble size is greater than 40. We want to actually, it equals 40. Let's debug it. Start index plus preamble size. Now I wonder if let's see. I think I can step up into these other threads, or these other methods here. So what is my current one? Current is 40? Is there a 40? Okay, so there is a 40 here. Current minus preamble size. So what is my preamble size here? Or what is that start index? Start index is 35. That shouldn't be right because 40 is at index 0, 1, 2, 3, 4, 5. So why is it giving me 35? The inspect range is from 5 to 20. I think I must be passing in this current inadvertently. Oh, yep, actually, so this start index, we went I. So the current index that we're at is I, we want to subtract, okay. That makes sense, okay. We were passing in the value instead of the index. Okay, so this did find the anomaly. Okay, so now let's just run it against the full input here. I'm gonna do my usual thing of day9-full.txt. Paste it in. Those are some huge numbers, man. All right. We're gonna go find anomaly in part 1 input. Day9 full. And then we're just gonna print this out. Now, this is not the most efficient solution, but number format exception. So this might actually be, we might actually need to use longs for this. So this might actually be exceeding the max int. 2.2 billion. So the max value for an int is, yeah, so we're exceeding that. Which is fine. We can just do we can make this a list of longs. This is going to be list of long. Current is input at I. Sums is going to be a list of long. Be a list of long, and then this will return a long. That's fine. And then the decoder test is going to be, we're just going to convert this to long. And I might even just factor this real quick. I'm just making this method even simpler, just to reduce some of that little repetition that we had. And let's just run this just as a sanity check. Return expression. Oh, yeah. That worked. All right, so let's find the anomaly in part 1. Oh, we want day9 full.txt. It's 38. Is that right? That seems pretty low. I guess it is. I mean, none of these add up to 38. Oh, except we have the wrong preamble. They want us to use a preamble of 25. Okay, yeah, that's a little more. Okay, so we'll do preamble of 25, and then we'll run that. I was like, that's too easy. There's no way. Okay, so that is a little more consistent with what I expected. It's one of these huge numbers here. We got it. Continue to part 2. The final step in breaking the Christmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list, which sum to the invalid number from step 1. So we found, oh, okay. In this list, adding all of the numbers from 15 through 40 of at least 2. So we don't, okay. Okay, so this is like 2 or more numbers that add up to this. This just got a lot harder. So you want to add together the smallest and the largest numbers in this range. So you want to add the numbers from 15 through 40. So the invalid number in this one was that 127, right? So then somewhere in this list there's a set of numbers that add up to it. The contiguous set of numbers in your actual list may be much longer. So these are like any subset of these numbers could be this number. It has to be at least 2. Adding up all of the numbers from 15 through 40 produces the invalid number, and then they want us to take the first and the last, or the smallest and the largest. So we need to find this contiguous set, and I think the one thing that we can leverage is that this is a contiguous set. We already have this number, so we need to do a different traversal of this list. And we need to find, it has to be contiguous. And so we could brute force this and go through each one of these and say, like this 127, we could take 35, 20, 15, and then as soon as we could add the subsequent numbers together, and then as soon as we exceed that number, then we can increment this index. So for each of these, we're checking whether this number and any n number of numbers after this, we're just going to walk forward and then sum everything together up until there. So this is going to be O of n squared complexity, which is, I mean, it's not great, but it'll work. And then you just, as soon as you find that contiguous set, you want to sort it, you want to add the min and the max together. I think this is not actually too bad. So I'm going to write a different method in this Christmas decoder to find contiguous set, and then I'm going to have a goal sum, which is a long, and then this is going to return a list of long. And then what I can do is call this method, get my list. I keep forgetting fun. So what happens when I'm recording myself? You make kind of silly mistakes. Okay, find contiguous set. And so we're going to go through, we need to look through everything. Actually, we don't need to look through everything in your list. Yeah, we do, actually. Right? Because I think we need to look through everything up until that anomaly. But I don't think it hurts us. We're gonna find it before then. So I think it doesn't hurt us to just search the entire list. Because in this case you're gonna run into it way before you've gone through the whole list. So we're going to need to do two loops. One is this start index, and the other one is the ones after it that we're going to be summing together. And then the break condition would be is if the sum exceeded that number, then we give up, then we bail out. So for I in inspect range, or not in inspect range, in input dot indices, because we do need to know the index. Yeah. We want I'm going to have a var of sum is equal to 0. And then we want to walk up above that. So for j is equal to I plus 1. I'm gonna make a while loop inside the for loop. It's a little kludgy, but I think a while loop is a better is more of what we want, because it'll be checking this condition. So for I in input dot indices, we're gonna say the sum. We're going to start it off with the sum is equal to input at I. And then we want to start j. J is also going to be a var, and j is going to be this second index that as we're walking up. J is equal to I plus 1. And then while the sum is less than the goal sum. So we also need to, another thing to keep in mind is we need to keep track of what I and j are. so that we can return this sublist here eventually. So for I in input.indices, the sum is less than the goal sum. Sum plus equals input at j. And then if the sum is equal to the goal sum, then we want to return an input of, starting at I, we want to do a sublist. Sublist of I to j, I think. Because we want this to be inclusive. We want an inclusive sublist. The other thing we could do is, I'm just going to do a sublist of I, comma j plus 1, because sublist is exclusive. Okay. So find contiguous. We want to do contiguous set. Okay, so in this case, we're expecting a list of 15 through 40. Input is parse input, day9.txt. We still need the input, so we're going to create that. We already know the anomaly though. Val anomaly is this 127L. I think, does this goal sum take a long? Yeah. And then this is also, I'm just also going to throw a runtime exception, because otherwise the compiler is going to complain. No set found. Okay. R2 using test input, and then val. I'm gonna say some set. That's not really a good variable name, but it's the set of numbers that adds up to that sum. Whatever. I don't care right now. Decoder dot find contiguous set of this at this anomaly, and then sum set dot min should be 15. Sum set dot max should be 47. And I know that this is telling me that these methods are deprecated. For some reason, I ran into this a couple days ago, but this version of IntelliJ and the version of Kotlin I'm using, it's going to tell me to use min or null, but it's not able to find it. Min or, oh, now it is. Okay. Whatever. All right. That wasn't working a few days ago. Max or null is the non-deprecated one. Okay. And then sum set, where we're expecting it to be 1, 2, 3, 4. Sum set dot size should be 4. Now let's just take a look at this, make sure. And hopefully we didn't write some kind of infinite loop. Sum set is a size 2. It's not what we want. So it gave us 47 and 40. I wonder if we just got the wrong sublist here, because it does look like it found it. Let's see what it found. So it did find it. Now where are we at? So we're at I is 4. Oh. We're not actually, oops. We want, Oh, so we were accidentally adding a bunch of stuff over and over again. So we want to increment j. The sum is at input j. So I think we accidentally got the right solution because we must have added one of these together too many times. So let's see if this gets us what we want. I is 2, j is 5, so 0, 1, 2, yep. 3, 4, 5, that's what we want. Okay, so now we have a list of size 4. The max is these. Okay, so now I'm more confident in this. So let's go part 2, full input. I'm going to parse this, day9-full.txt. We don't really care about the preamble size, but we'll just pass that in for whatever. And then the anomaly that we found is that 2 billion number here. And then we want to find the sum set. We don't know what size it is, but we're going to add these together. We're going to print ln, and we want to add together this min plus the max, or null. Compiler is angry. We're asserting that these are going to be here. So we like to live dangerously. Okay, so part 2, full input. We got day9full.txt, Christmas decoder. It blows up in our faces because it didn't find a set. What did we do wrong? Is that the right number? No, it certainly was not. I gave it the wrong number. I don't know where. Oh, this must be the int max. Okay, so now we should be able to actually get the right answer. Okay, we got it. It's this. The min and the max added together. That's right. We did it. All right, I'm excited. Thanks for watching it. Yet another Advent of Code. I've done 4 of these this weekend because I'm trying to catch up. It is the 13th and I'm on the 10th now, so I'm getting there. I'm getting there very close. I just need to do a couple other ones and I'll be set. All right, thanks again for watching. I'll see you next time.